All right, welcome back to the SEMA Collision Repair and Refinish stage. My name is Joel Dufkus. I'm one of the ADAS and EV instructors here at the iCar. And today I got Joshua Linton here from Midtronics. Joshua, what do you do over at Midtronics?
So I'm an EV platform manager at Midtronics, and I'm in charge of development of a whole bunch of cool new EV safety solutions that we're developing for collision repair, actually. Yeah.
Very cool. That's awesome. If you know me, I'm a big EV proponent. Been working on it for a long time. It's cool to see more equipment coming on the aftermarket for this type of stuff. So what do you got to show us?
Sure. So those of you who know Midtronics, Midtronics is legacy 12-volt battery management solutions for many years. However, the EVs do have a 12-volt battery. Did you know that?
Yes, I'm aware of that, but a lot of people don't know that. There's still a low voltage system that needs to be maintained to power computers, windows, doors, all that type of stuff.
That's right. That's right. And I'm going to let you in on a little secret. Testing a 12-volt battery in an EV to crank an engine doesn't make sense.
Because we're not cranking an engine, we're not pulling large amperage to crank over an engine, especially in the cold. We're trying to support and maintain, the low voltage system for computers and things like that.
Exactly, exactly. And so what's important to realize, I think, is that the 12-volt battery in the vehicle plays a different role depending on the technology of that vehicle. And so in an ICE vehicle, of course, it's responsible for cranking the engine. In an EV, it's responsible for powering all the low voltage loads in the vehicle, which are quite high, large amount of low voltage loads.
Yeah, we're seeing more and more computers and modules and things like that. Electronic power steering racks, big draw on those types of systems. So we need to have the battery be able to maintain that type of stuff and not drain out very quickly.
Exactly, exactly. And so here's a sampling of all the safety critical systems that rely on 12-volt power, in addition to all of the creature comforts and the features, accessories that make the vehicles fun to drive, right? 12-volt battery has a huge responsibility in an EV, but that's a capacity responsibility. So we don't need that high current spike. And so the point is that we need to diagnose the battery for its role in the vehicle. And so we've created a new technology specifically for 12-volt batteries in electric vehicles. And it's quite simply called safety power diagnostics. The reason for that is because it's responsible for powering all of the critical safety systems of the vehicle in addition to everything else. Yeah.
Yeah, it's very important to make sure we check that stuff and it's operating correctly, especially after a collision, right?
Exactly, exactly. We want to make sure that, especially that before the vehicle is returned back to the driver, that it has a healthy 12-volt battery to ensure that, of course, it's safe and it functions fine and the customer is satisfied, doesn't have any prolonged issues with the vehicle, right?
Yeah, so for those of you that don't know, especially with an EV, in the case of an accident, there's sometimes a pyro fuse that'll blow, that'll disconnect the high voltage battery from the main system, and the high voltage battery is what helps maintain that 12-volt battery. So it's like a alternator on an ICE vehicle. If we don't maintain that 12-volt battery because of all the computers and stuff going on in there, it's going to drain that 12-volt battery out. So potentially we could be giving a car back to a customer that has a compromised 12-volt battery, and maybe a week later, all of a sudden their EV won't respond or do anything because the 12-volt battery died.
Exactly. That's exactly right. And so we've created safety power diagnostics, which is the highest precision capacity diagnostic to make sure that in that scenario which you just described, where it's not being properly maintained and charged by the vehicle, that it hasn't lost capacity and it can still support the vehicle. And if it cannot, we can diagnose that to then in other words, replace the battery as a result, right? Bottom line is delivering a safe vehicle back to the driver.
Yeah, ultimately we return that car back to pre-collision condition. Exactly. So we want to make sure it's ready to go for them. We're not going to have any issues, and this is part of that process.
Yes, yes. So when we talk about 12-volt problems in EVs, right, kind of when this problem starts to occur, meaning that the battery capacity has degraded to the point at which it cannot support the vehicle, the no start is like the best case scenario, because in the worst case scenario, if the battery fails while the vehicle is being driven, or it can cause a serious safety risk to the driver.
It could potentially shut down the whole vehicle while you're driving if it
could
fail.
Yes.
So, real quick question to clarify: what kind of 12-volt batteries are we seeing in EVs? Are we seeing like a traditional lead acid type? Are we seeing AGM type stuff? We seeing lithium? What are we kind of seeing?
So it kind of runs a spectrum. We see a lot of flooded and a lot of AGM batteries. Typically, in general, OEMs are using a lot of the similar batteries they're putting in ICE vehicles in EVs as well. We have seen also with some of the newer EVs OEMs versus the traditional ones. The new OEMs are taking a different approach. In some are putting batteries that don't even have a CCA rating. It's really designed for that application. Yeah.
Because ultimately, we're not after in EVs. We're not after a CCA rating, right? What are we looking for more so?
We're looking for the sufficient capacity, in other words, amp hours or RC minutes, sufficient capacity to power the low voltage systems.
So we're looking for the amp hours and the RC, the reserve capacity of that battery to make sure it's correct for that vehicle.
Correct, yes. Yeah. Yeah, and just to show you an example, these problems do occur. There are safety risks posed to vehicles because of insufficient 12-volt power system issues, right? Or risk on this. And so, in this case, some vehicles had the 12-volt charging system failure, and so the vehicle, while driving, stopped supporting the 12-volt battery.
So that's essentially like when you're driving down the road in your ICE car and your alternator belt popping off and your alternator stops charging your 12 volt.
And then at that point, exactly, you have only the capacity and the stored energy in the 12 volt battery to support all the critical function of the vehicle. And if that capacity is degraded, there's risk involved.
And in a traditional ICE vehicle, it's going to last a little bit longer because there's not as many electrical loads on that, and usually they have a little bit more robust battery compared to a EV vehicle. So in an EV, if your DC converter, your power conversion system, whatever you want to call it, goes down while you're driving, that could be a quick turnaround to when that vehicle dies out.
Yes, it could be even seconds before not even enough to get you to the side of the road.
Because we're seeing some of these EVs with real small lithium type batteries that don't have a whole lot of capacity inside them.
Correct, yeah. And so this is just to give you a look at what we are now introduced to the market, which is XLVS 9000, featuring safety power diagnostics. So XLVS 9000 is the tool featuring this technology. There will be other tools to follow featuring this technology, but it's the most precise 12-volt lead acid capacity diagnostic available on the market today, and it's designed for this application. Yeah.
It looks pretty cool. It looks very Midtronics looking.
Yeah.
Is this something that's upgradable?
Yeah. So the hardware is actually well adopted by many OEM aftermarket service cases now, and actually this technology can be delivered in the form of this new tool and a hardware, or we can deliver OTA to existing hardware in the field. So it's pretty flexible. What we want to make sure that the vehicles are being diagnosed in the correct way given the application of the battery, and so we're taking a multi-prong approach.
Nice. That's important, the OTA updates, because as EVs come about, there's always new technology coming out, right? We're never going backwards. There's always something new coming out with every new vehicle. So having a tool that can be updated, when you guys see, hey, there's a new test procedure for this type of battery or something like that, you can go ahead and push an update to the machine, and I can have the most up-to-date machine possible.
Exactly, and that includes algorithm enhancement, and as we continue, and
you guys
vehicles change also, right? Yeah.
I know you guys do a ton of extensive testing with different types of batteries. You get all these different types of batteries from people and stuff like that, and you refine your algorithm, like you said. So once you guys come up with a better algorithm, you can push it out, and my machine can stay current, for a long time, right?
Yes. That's exactly the idea. Yes.
Is there anything else? Does that Could I do like ICE car testing with that system, or is this just strictly for EVs only?
That's a great question, and yes, it does. It's dual functional, so it supports 12-volt diagnostic across all vehicles, not only EV. And so, if you think about it in the dual function way, everything we're talking about, it supports in addition to conductance test on ICE vehicle 12-volt batteries to ensure cranking health, capacity diagnostic for ICE batteries, charge acceptance, diagnostic charging for both EV and ICE. So it's a full suite. It's pretty much everything we do.
It's not a one-trick pony tool. You can do a lot with it, right?
Not at all, yeah.
And this is cool too, because I've been able to check one of these out and stuff, and it's got the printer on it like we see on a lot of those, so you can actually have that printout, so you can go ahead and show the customer or whomever wants to see, why is this bad? Okay, here's the data that shows why this is bad. Is there a way to get any data from like the cloud or anything like that? Is this connected with that?
Yes, that's a great question. So we offer, all of our tools are connected to our BMIS, Battery Management Information System, and we collect data from every tool, every test, and we provide it back to the users through their own user portal. And so it's an analytical dashboard, and it's used for all kinds of warranty management on OEMs or vehicle service and data reporting for all of our customers. And so this fits right into that ecosystem. We have a barcode scanner to capture VIN and tie the whole thing together. Yeah.
Nice. So you can have the old school paper method, or you can do new school, cloud reporting, stuff like that. That's
right.
Cool.
That's right, yeah.
You guys have anything else cool coming up here? Any cool tools?
Actually, yes. We have a brand new high voltage safety tool, which is called XHVS 3000, and it's a brand new tool we've developed for EV safety right at the charge port. If we can show the tool right here on the table, it is. You plug it right in at the charge port, and it's a multifunctional tool which runs a suite.
Plugs in right here.
Yep, plug it right in there, and it's a multi-function tool that'll run a suite of diagnostics right at the charge port. It's intended to be very easy, fast, user-friendly. It's intended to be used by technicians who may not have level 3 high voltage training. They can still assess the safety of an EV prior and during collision repair, as well as, of course, prior to returning the vehicle back to the owner.
Yeah, we always want to make sure we check afterwards. Now this is just a prototype, right? This is not the final form of this tool yet, right?
That is correct. It's, let's say, directionally indicative of where we're going. It'll probably get a little smaller, a little slicker, but yeah, that's the nature of it, yeah.
All right, if we can go back to the slides here real quick, let's take a look at some of the stuff we can do here. So,
yeah.
Immobilizer. So what does that mean, immobilizer?
So we want to make sure that the vehicle, when you plug it in at a charge port, a charging station, for example, that it does not move. And when you plug XHVS into the charge port, we run that test as if we were a charging station, though we're not putting energy in the vehicle, to make sure that that charge port circuit is working properly.
Yeah, so we can simulate, basically you're simulating the tool to act like a charging station even though it's not charging, which then locks the vehicle out from being able to move and stuff like that.
Sure, exactly.
That way, if you're not sure if that car can move or not yet, like that's going to mobilize the whole system.
Exactly, yes, yeah.
And so we have an insulation resistance testing. So that's, we're not going to get too high level or too crazy down into this, but insulation resistance testing, a lot of manufacturers want us to do these types of testing after we've replaced modules or things like that. So this tool, has that built in, which is a pretty cool feature.
Right.
I think it's a great function for that tech to be able to do that stuff. Equal potential ground bonding. So what are we doing with that?
Yeah, so ground bond test, we want to make sure that the high voltage components of the vehicle are properly grounded, high integrity grounding to the chassis of the vehicle, right? And so with that test, we're plugged in at the charge port, and then we use a measurement probe to touch each high voltage component and measure that grounding integrity. Yeah. which can ultimately, if there's a problem with this test, it can compromise the safety and or the performance of the vehicle. So it's really critical. Yeah.
No, it's a pretty cool test on that too. AC touch current. So what is AC touch current?
So touch current is really it can be a dangerous issue when it arises, which is when there's a ground fault problem with the charging station and the vehicle has some flawed components because over time things come loose or degrade through vibration and weather, etc. Then the charging station won't be protecting the driver or any bystanders from because it has that ground fault in this scenario, and in that case with the vehicle would not either because of these failed components. And so the risk here is that there would be AC current flowing on conductive surfaces where it should not. For example, like door panel, handle, rims, any conductive surface, and someone who just touches it nearby could be electrocuted. The risk here is death.
Because we're talking AC power. So if you're on a level 1 or level 2 charger, like at your house, or like what they have at the mall, where it's like a free charger you plug into. Yeah. If that charger's not grounded to protective earth, the car helps take over that. But if the car is not also protected, then we could lead to some sort of issues in a failed componentry or failed charging station situation. So this will help detect that type of stuff.
Yes, it's critical, and we measure milliamp value on this test, so we want to make sure, and it's a very tight threshold on that. We want to make sure it's safe.
So we're really getting down to the nitty gritty there, making sure that we're safe.
Correct. Yeah.
And then we have our DC isolation resistance test. So what are we doing with that one?
Yeah. So DC isolation resistance is checking the safety of the high voltage battery directly from the charge port, and so this is when you have a problem in this related to this, then that's the one we see in the headlines often, right? With the worst case scenario with the battery fires. And so in this case, we're measuring anything that could compromise the safety of the high voltage pack. So in other words, we just had hurricanes, right? What about all the cars that got flooded? Has water entered the pack or not, right? Well, probably nobody knows for sure. This test would tell you if that was true, for example. Yeah.
The other good thing about this one too is the DC fast charging cables go to that charge port. That charge port's on the exterior of the vehicle. For collision technicians, that's a big area where that car's going to get hit in that charge port that could damage those wires. And we do a typical isolation test. It doesn't usually test from the battery pack to the charge port. It's not usually online there because there's separate contactors for that and they don't get tested. But this tool, by plugging it in, we can actually test that and verify that that's good or not to make sure that those wires weren't damaged during the collision or things like that, right?
As well, correct, yes.
That's pretty cool.
Yeah.
Anything else we got with this tool? Seems like it does a lot.
It does a lot. It does a lot, yeah. It's intended to be very easy to use, but be very comprehensive in what we're testing for. Yeah.
Does this also, like we talked earlier with like your tools that connect to the cloud and stuff like that, does this connect and we can extrapolate data off of here?
Yes. We actually have an interesting integration strategy with this tool. Essentially, basically two method. One, it fits right into our BMIS battery management information system for analytics that we provide for our customers, or it can be a measurement device which integrates into, for example, a collision repair or a customer's data reporting system as well. So different approaches, but it can serve as either. Yeah.
Very cool.
Yeah.
Well, I look forward to seeing this thing come to market here. It's been cool seeing it progress through its different stages.
Indeed. Thanks.
Do you have anything else Midtronics is working on yet, or?
Yeah, we have one other thing that we can chat about.
Yeah, we got like less than a minute, so we'll talk real quick.
Yeah, so which is a vehicle immobilizer, and basically we talked about HVS does the immobilization test. We're also doing a standalone immobilizer tool. Essentially, collision vehicles are by definition unpredictable. Don't know what you're going to find, and so essentially, plugging our immobilizer tool into a collision vehicle ensures that, like on vehicle intake or initial inspection, whatever, there won't be any unpredictable movement, any unpredictable behavior. So we're developing this for firefighters, tow trucks, collision.
Yeah, those first and second responders that are going to these accidents.
Yeah.
It's a very cool
Exactly.
tool. Well, Joshua, thank you very much for coming out here and talking with us. It's always cool to see all the stuff Midtronics is working on. If you guys have any questions, we'll be at the side stage here if you want to know more. But thank you guys, and we'll see you later.
Thank you.
Midtronics. We will get you there.